Hi, I'm Jake Warner. I'm the CEO and founder of Cycle.io. For those of you who might be watching this video that are new to Cycle, Cycle is a infrastructure management and container orchestration platform. The goal is how do you provide developers, DevOps teams, platform engineering teams a more purpose-built and simpler way of deploying applications, regardless of whether it's something very simple or something more on the sophisticated side. But how do you do that in a simpler way that kind of allows you to remove a lot of the traditional complexities associated with deploying things of that nature, right? But today's video, we are going to specifically talk about a new feature that we've been working on for the last 4 to 5 months, and that is a load balancer. Again, and for those of you who might be new to Cycle, your first question is why, or might be, why are we building a load balancer? And in a nutshell, the entire Cycle platform has been built in-house by our company. And the general idea is that instead of having to kind of piece together things that you would normally need to do with a lot of kind of the cloud native frameworks, the goal of Cycle is to provide all of those traditional features in one single package. That way everything is purpose built, everything is deeply integrated, everything works together, you get better performance, better reliability, etc. And for most of the platform, that has been the case, except for load balancing. For most of companies been around for 6 to 7 years at this point, and we've been using HA proxy, but it has become time for us to launch our own load balancer. That way, the load balancer can gain many of the benefits that are provided with the rest of the platform. Because again, given how integrated everything is, given how everything is already integrated with the platform, we already have so much visibility into everything that having the load balancer be able to gain that same observability and kind of automatic configuration, et cetera, by being plugged in natively to the rest of the platform is a big win for our customers. So without further ado, let's dive in. So within Cycle, we have environments. This is a demo account that we have up and running. And we'll specifically jump into this demo environment. In Cycle, each environment is its own fully private network. That network can extend across different infrastructure types. It can exist across different regions. It can exist across different infrastructure providers. But for this example, we're just going to work with this demo environment that has 9 containers inside of it. On Cycle, each environment gets its own load balancing service, its own discovery service, etc. But again, today's video is specifically about the new load balancer that we're releasing. This load balancer has been technically on our production cluster for 5 or 6 weeks now. It has a beta tag on it. We definitely, at this point, this is December 2023 as this video is being made, we do not at this point recommend that you use this load balancer with production environments, but if you have a development or staging environment on Cycle, we'd love for you to run this load balancer on or opt in for this load balancer. That way we have more users testing it. But again, the main goal right now is to not use this in a production environment yet. But if we jump into this environment, we'll see the load balancer service here. We can click manage. And under settings, you'll see this is where you can opt into whichever load balancer type you want to use. By default, the platform on Cycle is still HA proxy, but if you'd like to opt into the beta, you can do that here. And once you opt into the beta, you'll start to see more of this telemetry information that is being pulled from the native load balancer, where with HA proxy, we didn't have a huge amount of visibility, at least visibility that we could natively show within the portal. And now with the new native load balancer, we do. So we can see on this dashboard just some very high level metrics. Again, this is a demo environment, so there's not a lot of traffic coming into this environment, but we can see bandwidth, we can see connections, requests, disconnects, etc. In this specific environment, we have the load balancer running in HA, which means that we are running one copy over on GCP and another copy over AWS. That way we have redundancy. For this environment to be offline, we would need both of those load balancers to be unavailable. We can see the console that is associated with each of those individual instances, basic instance telemetry, so CPU usage, RAM usage, network traffic, etc. But with this native load balancer, we can also see this traffic interface that allows us to have more visibility into underlying traffic. So if we go into the traffic modal or screen, we can click one of the controllers. Each of these controllers is just an active port that is open on that load balancer. We can see this load balancer again has those two instances, one on AWS and one on GCP. In this case, they're both in Ohio. Again, this is purely a demo environment, but we can see the amount of data transfer, connections, requests, disconnects, etc., broken down per load balancer here. We can also open routers and get a little bit more into the weeds. So from here, we can see, again, the first load balancer and the second load balancer, but then we see the destinations that they're routing to. So these destinations here, they're not other load balancers, they are the underlying containers serving the requests for any traffic that is entering this load balancer. And so we can see in this particular situation, all of these instances that are serving requests for the particular demo here are AWS. So coming from the AWS load balancer, we can see the latency is very low. In fact, in this case, it's 0. It's running on the same server. But for the load balancer running over at GCP, you can see there's some latency, which would be expected because you're jumping between cloud providers. And again, this is a very basic example, so that's why it seems a little bit skewed, but whatever. It is what it is. But at the same time, we can see the number of requests that are going to each of these destinations, the amount of traffic, and then the success rate. So that's routers. We can dive into if the load balancer is running in if the controller is running in HTTP mode, we can see a breakdown of the individual HTTP requests. So this is the requests that are coming into the load balancer, the path, the domain. We can see what method was being requested. We can see the response. So in this case, hitting the main URL here, we have a few 200s and a few 304s. We can also see which handler is processing that request. And so the load balancer has 4 handlers today. We have a forward handler, we have a cache handler, a proxy handler, and a redirect handler. Redirect is exactly what you'd expect it to be. Proxy same, caching same. Forward, I guess also same, but forward just implies that that request made it through the load balancer to a final instance, as opposed to where caching means that the load balancer was able to handle that response without ever needing to talk to an underlying instance. And then at the same time, we have our average time here. So this is the average request coming in. We've had 107 requests that have come into the load balancer. The average amount of time to handle each of those requests was 10 milliseconds. And if we look down at like a CSS file or a JavaScript file that is being cached based off of the configuration we specified for this load balancer, we can see that for some of the cases for the CSS and JS file, they were cached, and we can see the breakdown of the amount of time spent handling the cache request versus the amount of time spent forwarding to the underlying instance. If we want to get into the weeds a little bit further in terms of why is there caching set up for this and how would any of our customers configure that, we'll jump over into config. We can see those same controllers that we saw before for traffic, but now we're talking about them from a configuration perspective. So kind of walking through some of the settings here. The identifier is just that'll be the identifier will be used more commonly when we start to have more in-depth telemetry and logging, where we allow users to kind of define that criteria a little bit more specifically, and then also be able to reference specific controllers in more of a reporting way. So anyway, that'll become more important later on. Then we have our ingress port, which is purely what is traffic going to enter this controller with, what mode do we want this controller to operate in, so HTTP versus TCP. Those are the 2 modes we support right now, which is most traffic. We have other modes that we'll be adding over time, but those are the main 2 today. Logging verbosity, self-explanatory. Idle timeout, also self-explanatory, but very simply, how long do you, if a connection connects to if you have a client connect to the load balancer, how much time should pass without traffic before the load balancer kills that connection? In this case, it's set to 60 seconds. And then we have this performance checkbox. This performance checkbox just pretty much tells that specific controller to spend any extra time that it might be spending on telemetry to disregard that and put all of its focus, all of its resources towards handling actual requests. Now, during all of our testing, we have not had to check performance for anything. The load balancer has been performant enough without it. But if we have a company that is using Cycle that they might have a massive amount of traffic where that's collecting telemetry is maybe a little less important to them. They can check this performance box and gain that little bit of extra few percentage of gains, but for most people, it's not something that people will have to worry about. Now, as we continue on, we can see routers here. The important thing that I want to specify with these routers is that these routers are not necessarily defining like moving traffic around. Instead, they can be thought of almost as modifiers. So behind the scenes, because Cycle already knows what domains you want to use, what containers are going to be specified here, what domains are used, etc. Since Cycle already knows all that information, Cycle pre-configures the load balancer to be able to handle all those requests as would be expected. The routers here are for if you want to customize if you want to modify how that traffic is being moved further than what Cycle is saying specifically. So even though this router here is only talking about api.thecenofrain.com, which is just an example URL, even though this router is only talking about that, there's still many other domains that can be passing through this this load balancer. They'll just be hitting maybe some of these other rules to impact how their traffic is, or how the traffic for those containers is being passed through the load balancer. So if traffic is coming in to this load balancer and it is destined for a container listening on port 8000, and the traffic is specified, or the domain for that traffic is api.thecenofrain.com, then it will use this configuration. And so you can see here that this is just basic what mode we want to use, what domains we want to match, what the internal container is going to use, etc. But for any other traffic that would be coming into this through this load balancer that is coming in on port 443 publicly and is passing to any of the other containers in this environment that do not match any of these other rules, they would hit this kind of this catch-all at the bottom. And so if we look at that, we can see still we're going to round robin that traffic. We're not matching any domains or ports. We're not matching any path. But then you can see there's an extension specified here. And so an extension is a JSON blob that allows you to get really into the weeds with how you want to manage redirections or forwarding, those handlers that I specified earlier. And so in this case, we can see that caching is set up. So in this case, we're saying we want to cache files. Any files that end with this extension, so this is .js, JPG, CSS, PNG, and SVG, and we will want to cache those on the load balancer for 15 minutes. But again, the main point of these extensions is that it allows you to say, hey, any traffic matching this initial subset or this set of criteria, here's how we want to modify that traffic or handle that traffic to be more specific if we need to. Then we can configure TLS if we need to. By default, the Cycle says, hey, this is 443. We're going to guess that you want TLS enabled, so we do. But if you need to get more into the weeds and set up client auth and things like that, you can. And then just a couple other configurable things down here. But again, everything that you're seeing right now is still technically in beta. There's a lot of other things that the load balancer allows us to do that are not exposed yet. We'll be adding that functionality over time, or rather exposing that functionality over time. But this is kind of the first step that we wanted to open up to our users to make it easier to open to our users so that they could begin exploring the new load balancer, helping us test it, etc. But yeah, that's the new load balancer kind of in a nutshell. And for anyone who's currently using Cycle, if you'd like to help us give this a test, like I mentioned previously, please do not use this on a production environment yet. But if you have a development or staging environment, opting in per environment would be very helpful to us. If you encounter any issues, we'd love to hear about those, and we'll solve them and get them out in the next update. I think that's it. For anyone who's seeing this video who's not familiar with Cycle, we do have a community. You can join that community. It's slack.cycle.io. There's a lot of people that hang out there, whether it's founders or developers or DevOps engineers or platform engineers. There's a lot of people that hang out there. So we'd love to have you join our community. And yeah, if you have any questions, please reach out. Thank you.